Good morning children. In today's class we are going to learn about stationary point and stationary value. We had already learned curves may go up and down like this. Here I will say the curve is increasing, whereas here it is decreasing, increasing, decreasing and so on. Increasing tells me first derivative greater than 0. Here it is less than 0. Again greater than 0. Again less than 0 and so on. How about greater than 0 to less than 0? There will definitely be a point or a stage where derivative is equal to 0. Similarly, from less than 0 to greater than 0, again I will say f dash is equal to 0. So these are the points where the curve is standing still. It is neither increasing nor decreasing. Such points where the curve is standing still, I call stationary. The word stationary tells us standing still. No movement, no increasing, no decreasing. So, stationary point, we have the condition f dash equal to 0. When I put f dash of x0, I will get some x value, call it as some a or x0, x1 like that. When x is equal to a, find out f of x, or I will call f of a. This a comma f of a as a point form I write, which I call stationary point. F of a I will call stationary value. So in this exercise we are going to learn about stationary point and stationary value. What are the steps? Make the derivative 0, get x value. That x value, put it back in f of x, find some value. That I call stationary value. If I represent it in point form, it is stationary point. Let us do some example problem. Example 6.21, find the stationary value and stationary points for f of x equals x square plus 2x minus 5. When f dash is positive, it is increasing. When f dash is negative, it is decreasing. When f dash is equal to 0, it is stationary, standing still. So for stationary point, find out f dash, make it equal to 0, get x value, put it back in f of x. So that x value and f of x value gives the stationary point. Let us use this condition in this problem. Find out f dash of x. X square becomes 2x, 2x becomes 2. Minus 5 being constant becomes 0. F dash of x equal to 0 implies 2x plus 2 equal to 0. 2x is minus 2 or x is minus 1. Put x minus 1 in f of x. F of x is equal to minus 1 square plus 2 into minus 1 minus 5, or f of x is equal to 1 minus 2 minus 5, that is minus 6. Let us take and write the answer. Stationary point is minus 1 comma minus 6. Stationary value tells us that f of x value, that is minus 6. We proceed on to another important idea, say absolute extremum. We already learnt about local maximum and minimum. In this example, we are going to learn how to find out absolute extremum. That is absolute maxima and absolute minimum. Before going into this, let us learn what it is. Look at these curves. Here, there is no interval given. This is the interval. This is the maximum. This is the minimum. This is the absolute. This is the The curve goes on and on up to plus infinity and minus infinity. Such curves will not have maximum, but it will have a minimum at this point, that is 0. There are curves like this. Look at this line. It goes on and on. This side also it goes down and down. This side it goes up and up. Such curves, no maxima or minima. So here minimum is there but no maximum. It goes on and on. Here it goes on and on, up as well as down. So here no maxima, no minima. Look at this curve. This is not having maxima or minima if interval is not given. But they have given an interval A, B. Check the interval. If it is open interval, now also there is no maximum or minimum. Suppose if it is a closed interval, then we can measure the distance. If it is a closed interval, I can measure. The highest I will call maximum, the lowest I will call minimum. But open interval is given, no maxima, no minima. Look at this example. Here you are given a closed interval. It starts from A and ends at B. The line goes like this. Measure the heights. This height I can check, which is the highest out of all the y values. This is the highest and this is the lowest. So whenever there is closed interval, definitely there will be a maximum and there will be a minimum. This we call absolute extremum. So absolute extremum is available definitely if it is a closed interval. When it is an open interval, it may be there, it may not be there. So how to find out this absolute extremum? Using the calculation. Very first step, find out f dash of x. Second step, find out where f dash of x is becoming 0 and where f dash of x does not exist. These two together I will call critical numbers. So check where f dash is 0 and f dash of x does not exist, and hence we mean we find out the critical numbers. Number 3. Find out f of x value at critical numbers and at n points also. Given the interval a, b and f of x value at a, at b. Also these points. Out of all the values, the maximum is called absolute maximum and the minimum is called absolute minimum. Every problem with closed interval, when f of x is continuous, will definitely have an absolute maximum and an absolute minimum. Example 6.26, find the absolute maxima and absolute minima for f of x equals 3x power 5 minus 25x cube plus 60x plus 1. What is the condition for absolute maxima or minima? Find out f dash of x, make it equal to 0. First step, 3 into, as I differentiate, x power 5 will become 5x power 5 minus 1. Remember the formula, x power n derivative is nx power n minus 1. So 5x power 5 minus 1 minus 25. X cube becomes 3x square plus 60 into x becomes 1. 1 constant will become 0. So f dash of x is equal to 15x power 4 minus 75x square plus 60, from which we can take 15 as common. We are left with x power 4 minus 5x square plus 4. Condition for absolute maxima, we put f dash of x 0. So 15 into x power 4 can be written as x square the whole square, 5 into x square plus 4, that is 0. Factorizing 4, I need minus 5. The two numbers are minus 4 and minus 1. Minus into minus plus, 4 ones are 4. Minus 4 minus 1 is minus 5. 15, when I bring it to the other side, it is gone. Instead of x, I have x square minus 4 into x square minus 1, that is 0. So the question we reframe. X power 4 is written as x square the whole square. Here x square. So it is an equation in x square. So how do I factorize and write? X square minus 4 into x square minus 1, or x square minus 4 0, x square minus 1 0, x square is 4 or x square is 1, giving us x is plus or minus 2 and x is plus or minus 1. The n values I have to include. So altogether, how many answers I have? I have minus 2, minus 1, 1, 2. N values minus 2, 1 I have to include, but they are already here. In this, which all belong to the interval, minus 2, minus 1, 1 belong to the interval, but 2 does not belong to this interval. So, consider only which all belong to the interval. Minus 2, minus 1, 1 belong to the given interval minus 2 to 1. This tells me all the values between minus 2 and 1. As I have found out, put each value of x in f of x. When x is equal to minus 2, f of x is equal to 3 into minus 2 power 5 minus 25 into minus 2 cube plus 60 into minus 2 plus 1, or f of x equals 3 into minus 32 minus 25 into minus 8 minus 120 plus 1, or it is minus 96 plus 200 minus 120 plus 1. Altogether my answer is minus 15. Similarly, put the other value. When x is equal to minus 1, what is f of x? 3 into, substituting here, minus 1 power 5 minus 25 into minus 1 power 3 plus 60 into minus 1 plus 1, or minus 1 power 5 when it is odd number. My answer is minus 1. Minus 1 into 3 minus 3. Minus 1 power 3. Again it is odd number. So my answer is negative. Minus into minus plus 25. 60 into minus 1 plus 1. Altogether my answer is minus 37. Similarly, substitute x is equal to 1. F of x is equal to 3 into 1 power 5 minus 25 into 1 power 3 plus 60 into 1 plus 1. That is 3 minus 25 plus 60 plus 1, and my answer is 39. There are three answers: minus 15, minus 37, 39. Out of the three values, 39 is the maximum. Call it as absolute maximum. Out of the three values, minus 37 is the smallest. Call it as absolute minimum. So, in absolute maxima minima, we do not find second derivative. Find the first derivative, make it 0, get x values. Choose which values are in the given interval. Include the endpoints also. The values that we found out inside the interval, let us substitute in f of x. Out of all the values, the smallest is called absolute minimum and the biggest is called absolute maximum. Let us take and write the answer. Absolute maximum equals 39 when x is equal to 1 and absolute minimum equals minus 37 when x is equal to minus 1 and hence the problem.